Hello and welcome back to Maths with Mr. Duffield. I am the aforementioned Mr. Duffield. I'm going to work through this question that I've been forwarded by one of my LE. It's on finding common denominators in algebraic fractions to solve an equation. It'll involve forming a quadratic at one point as well, so lots of little elements happening. Let's get started. First of all, to join these two fractions together, let's find the common denominator, and we find that by multiplying the numerator and denominator of each fraction by the denominator of its opposite. What I mean by that is, let's times the top and the bottom of this fraction by x minus 2. X minus 2 top and bottom. And then on this fraction over here, let's times the top and the bottom by x plus 1. Now, you might be asking the question, sir, if you're doing that to each of these fractions, what about the number 3? Doesn't that change? Well, the answer to that is no, because we're timesing top and bottom of this fraction by the same thing. It becomes equivalent in the same way that 4/8 is the same as 1/2. It's still the same size, so they're still going to add together to make the same number. Let's write the next line of work based on what we've done here. X plus 1. X minus 2. Okay, and then this other fraction will be 2 times x plus 1. And then on the denominator, I know that they're this way around on the denominator here, but we can write them in the same order as the first fraction. And it's a good idea too, because we're trying to establish that the denominator is the same. We can swap these fractions around, these brackets, around, because of that commutative property of multiplication. They're being times together, and it actually doesn't matter which way around they go in the multiplication, they're going to make the same thing. Okay? Doing that helps us see that the denominator is the same here. So we can, pop an equal 3 there, because that's still there. We can group that into a single fraction. X plus 1, x minus 2. And on the numerator is going to be those fractions, those brackets, I'm getting confused between the word fraction and bracket. That's not very useful at this stage, is it? Okay, so we have each of those single bracket expansions in a single fraction, as numerators of a single fraction. Of course, multiplying those out, that times that, that times that, and 2 times that, and 2 times that. Simple single bracket expansion. Let's expand them out and see what happens. 4 times x, 4x, 4 times negative 2, minus 8, positive 2 times x, plus 2x, and then 2 times 1 for plus 2. All right, we've just expanded that top half of that fraction, that numerator. And the next bit is to just simplify all of the x bits and the number bits and see what happens. 4x plus 2x, 6x, negative 8 plus 2, that makes negative 6. The denominator, the bottom half, is the same as it has always been. And then equals 3 stays the same as well. Okay, so we've gone from having two separate fractions here to having been brought together into one with a common denominator. All right. Next stage is to actually take some steps towards actually solving this, making this even more simple, getting x on its own. My first step to that is going to be to cancel out this denominator. I'm going to times both sides of this equation this time by that denominator, x plus 1 and x minus 2. Okay, but 3 is going to be multiplied by x plus 1 and x minus 2 as well, because at this stage we're timesing the entirety of this side of the equation by a number, so we have to do the same thing to the other side. You should see that this is different from what we did initially. I was just doing equivalent fractions to find the common denominator here, which is why 3 wasn't multiplied. But down here, because I'm multiplying the entire of the left-hand side of the fraction by this, the other side of the fraction needs to be multiplied by the same thing in order to keep things equal. All right? It's a subtle difference, but it makes a significant difference to the answer, to your accuracy. So this denominator disappears when it's multiplied by itself. When this fraction is multiplied by the denominator, I end up with 6x minus 6 on the left, And on the right hand side, just moving this down a little bit more, excuse me, 3x plus 1, x minus 2. Okay? Now, this double bracket, you should almost go into autopilot at this stage. We can expand that out. We can work through and expand that bracket. And it's a FOIL, isn't it? That times that, that times that, that times that, that times that. Which makes x squared minus x minus 2. That is what it should come out as. If you know how to do FOIL expansion, that's no problem. If you're not sure, I'll double back and take a look at FOIL expansion. That's okay. We've got the time. The next stage of this is to expand this single bracket out with that 3. Each of those terms inside the bracket gets multiplied by 3, so we end up with 6x minus 6 equals 3x squared minus 3x minus 6. And yeah, we have a quadratic expression here. We have a quadratic equation, excuse me. So we can get to solving this by making it equal to 0, right? If we take away 6x from both sides, and if we add 6 to both sides, it ends up equaling 0, this quadratic, and that means that we're able to solve it. Having done that, what we should get, move up here and create some more working space. What we should get is 0, because we've added that 6x, we've added that 6 and taken away that 6x, equals 3x squared, and then negative 3x take away 6x is minus 9x, and actually this negative 6, let me move over again and show you, this negative 6 is having 6 added on to it, so this actually cancels. So we end up with 0 equals 3x squared minus 9x, which is actually relatively straightforward to factorize and solve. It's a single bracket factorization. The common factor, the common thing in both 3x squared and minus 9x is 3x. I'm opening up a single bracket. What would I times 3x by to make 3x squared? The answer is x. What would I times 3x by to make negative 9x? That's minus 3. And then we have our two parts, our two values that are being multiplied together, and the answer is 0. So either, for the product of these two things to be 0, either 3x is to equal 0, or x minus 3 has got to equal 0. What values of x make that the case? Well, for 3x equaling 0, x has got to be equal to 0, or for x minus 3 equals 0, what do I take away 3 from to make 0? Well, that's got to be 3. Okay, there you go. 3 take away 3 equals 0, so x has got to be equal to 3 for that particular case. We have our two solutions for x for this equation, that we started with. And you can try substituting them in and seeing what happens. Hopefully you should notice that indeed it works, and that this statement proves true. Lots and lots of steps to this process, so much going on, and I will forgive you for looking at it and thinking, do you know what, sir, I might need a bit more time looking at that. I'm happy to work through more examples if you like, but obviously the worksheet that I did set you, I asked you to do questions 1, 2 and 3. This is question 6, it's the kind of sharper end of this. If you feel like you get what's going on here, do keep going with the rest of this worksheet. I encourage you, please. Don't panic if that answer is maybe not for me right now. We can always come back to it another time. Well done for sticking with me. I wish you all the best in all of your endeavours, and when it comes, a very restful summer break. I will speak to you very soon.